so I want you to read this quick start and try and do it by yourself. So go ahead and read it and try and do it by yourself. Alright, so hopefully you pause this video and you try to do it by yourself. If you're not trying to do it by yourself, then you're not trying to learn, okay? So make sure that when I ask you to pause it, you pause it and you honestly attempt to do it, okay? The average restaurant dessert in 1986 had 200 calories. In 2016, the average restaurant dessert had 416 calories. What is a percent increase in the amount of restaurant calories? So hopefully you found your keywords. Hopefully one of your keywords was percent increase. Whenever we find percent increase, hopefully you realize that we're going to do percent of change. So we're going to do change over, fill it in if you haven't already. Original equals percent over 100. All right? So whenever we find the change, what do we have to do? Hopefully you said subtract. So what we're going to start off with is 416. Make sure you put your big number on top. Minus 200. 6 minus 0 is 6. 1 minus 0 is 1. 4 minus 2 is 2. So we get 216. Now that is not our answer, okay? If we were in elementary school, maybe, but not here. So we're going to use that change in our proportion over our original. What was our original? Remember, original came first. What came first, 1986 or 2016? 1986. So 200 goes on the bottom, equals x over 100. From there, you cross multiply and divide. So 216 times 100. I'm going to let you do the math, but your answer should be 21600. Okay, but you do the math. Then we have to divide by 200 because we use both of those in our multiplication. So now we're left with this one. So 216 divided by 200. Oh, 0, 0. So I'm going to let you do the division, all right? But you should end up with 1. Okay, that's what you should end up with. All right, so you do the division, but this should have been your final answer. Okay, if you need help solving this, just let me know when I get back tomorrow. Okay, so what we're talking about today, yesterday we talked about how in order for things to be a scaled copy, right, they have to be the same shape. All right, and we're going to take that same idea and we're going to apply it today to kind of figure out what other conditions do we need. Okay, so we're going to fill in these other two conditions for similar figures. All right, so let's go to this page, corresponding parts. Here's a figure of two copies with some points labeled. So we have an original copy 1 and copy 2. Now, I want you to take a second. Which one is a scaled copy? Pause the video, circle the one that's a scaled copy. So hopefully you said this one was a scale copy because it's the exact same. This one is stretched out, so it's not a scale copy, okay? So then we're going to go here. Complete the table to show corresponding parts in the three figures. What do you think corresponding means? Take a second. Think about it. Corresponding means in the same location. Okay, we're going to talk about that more when I get back, but it basically means the same location. So if we look at point L here, point L is right here. Point L in copy 1 is in the same location as what? Hopefully you said point B. And then in copy 2, point L is with, hopefully you said point V. Okay? Now I want you to take a second and try and fill the rest of this out. So pause the video, see if you can figure it out. Alright, so segment LM. LM is here. That goes with, hopefully you said CB. I'm just going to write CB. And then in copy 2, see if you can figure it out. Hopefully you said WV. Alright, if you can go and do the rest, pause the video, go do the rest. Alright, so the next one says ED. ED is right here. ED in this one goes with NO here. And then it goes with XY here. Or actually, ED, so it goes with YX. Make sure you keep it in the same order, right? So it says ED, so you want YX. And then this should be OM. Okay. Alright, so pause the video, do the rest of them. Alright, so hopefully you filled it out. And you got this. Whenever it says angle KLM, KLM is this whole thing right here, okay? So this whole thing goes with this one. All right, so hopefully you got that. Please don't just copy the answers. Try and do it, because that's the only way you're going to learn how to do it, okay? So is either copy a scaled copy of the original? Explain your reasoning. Well, we said earlier that copy 1 was the scaled copy because it's the exact same size. This one is stretched out, so it's not, all right? So make sure you have an explanation here. Now, 3, using tracing paper, compare the angle LMN and its corresponding angles in copy 1 and copy 2. What do you notice? All right, so we're not going to use tracing paper, but I'm going to do a demonstration. I want you guys to just pay attention, okay? All right, so I'm not using tracing paper. I'm using a sheet protector. But anyway, so it says to use tracing paper to compare angle KLM. So I have KLM right here, and I traced it. And it wants us to compare copy 1 and copy 2. So if I look at the original, I'm going to move it over to copy 1. What do you notice about that angle? About this right here? From that to this, what do you notice? So write it down, write what you notice. Hopefully you wrote that they are exactly the same, okay? When I move it over here, it's exactly the same. Now, if I go to copy 2, though, what do you notice? So from copy 1 to copy 2, what do you notice? Hopefully you said that they are not the same, okay? This one's a lot bigger than the one for copy 2. So what do we notice? For the scale copy, the angle is the same. Now, using tracing paper, compare the angle of NOP to its corresponding angles in copy 1 and copy 2. What do you notice? So, NOP is right here. So the angle is inside. It's in the middle. So what do we notice from this one to copy 1? So what do you notice? Hopefully you said it's the same. It's because it's exactly the same. And then between X, Y, Z, what do you notice? Hopefully you said that this one's smaller because this one keeps going out. So X, Y, Z is over here. So there's a whole bunch of other space. Okay? So what do we notice? We notice again that the scale copy of the angle is the same. All right? So whenever we have scale copies, the first thing that needs to happen is, like we said earlier, so it has to be the same shape. And then the second thing, in order for it to be a scale copy, like what we found here, is that the angles have to be the same. Okay? Now, the next thing, flip it over, so back to where it says scale triangles. So we have a whole bunch of triangles here. I'm not going to assign you 2 triangles because I'm not here to assign you 2 triangles, but we're just going to look at all of them together. We're going to figure out whether all of these triangles are scaled copies of O, okay? And then we're going to explain. So take a second, pause the video. Are A and the original scale copies, yes or no? Hopefully you said no, because they are completely different. Remember, a scale copy, they have to be the same. They just are bigger or smaller, but they have to be the same. Now, if you look at B and O, are they scale copies? So hopefully you paused it and found that they are scale copies because, look, they're exactly the same. C, do you think they are scale copies? Well, they look the same, so it could be a scale copy. I'm going to put a question mark because I'm not sure. D and O, are they scale copies? Well, I'm not sure, but they look alike, so I'm going to put a question mark. H, do you think they are scale copies? Well, if you look between 4 and 2, to go from 4 to 2, you have to divide by 2. But does 3 divided by 2 give you 2? Hopefully you said no, so this is not a scale copy. For E, if we look at E, is this a scale copy? Hopefully you say yes. To go from 4 to 8, we multiply by 2. 3 to 6 times 2. 5 to 10 times 2. F, is that a scale copy? Hopefully you said no, because they look completely different. And G. Well, I'm not sure. I'm going to put a question mark because I am not sure. Alright, so what we're going to do now is we're going to figure out if these ones that we put question mark with, are they actually a scale copy? Alright, so to go from 4 to 5, can you guys figure out how to go from 4 to 5? If you can't figure out 4 to 5, how about 3 to 2? How about 5 to 5.39? Alright, so hopefully you did some type of math. If not, we're going to do it together. So whenever you're trying to figure out if it's a scale copy, you're going to take figure 2 and divide it by figure 1. Okay? So if this is our figure 2, pick a side that you want. So I'm going to pick 5. For figure 1, what side goes with 5? And then I'm going to divide. So top in, bottom out. Now I'm going to do the next one. Figure 2 divided by figure 1. Top in, bottom out. 3 cannot go into 2. 3 goes into 26 times. Are these two numbers the same? If they are not the same, it is not a scale copy. If they are the same, then it is. So let's look at D. See if you can figure out if D is a scale copy. So if you look, 4 divided by 2, 4 divided by 2 gives you 2. Well, 3 divided by 2, if I write 3 divided by 2, oh look, that's this. And 5 divided by 2 is that. So this actually is a scale copy. And if we look at this one, well, these two are fractions, so that was going to be hard to do, but I can figure out this one. So go ahead and figure out this one. So I'm going to say, okay, how do I go from 4 to 8? Well, 4 to 8, I times it by 2. And then, how do I get this divided by 3? Well, hopefully it's just divided by 3. So if I multiply 5 times 2 over 3, what do I get? 5 times 2 is, 3 times 1 is, oh look, that is what we had. Now this one, 3 times 2 over 3. 3 times 2 is 6. 1 times 3 is 3. 6 divided by 3 is 2. Oh, look, that's what I wanted. So this is a scale copy. Alright, so down here, I want you to fill this in and then come up with the scale factor. What do we multiply it by in order to get from the original to the other? Alright, so hopefully you guys filled it in. It should look something like this. This is what you are multiplying to go from O to the new triangle, okay? Now, for this one, for D, here we were dividing by 2, alright? Dividing by 2 is the same as multiplying by a half. So that's why I put times a half instead of divided by a half, because when we do scale factor, we are multiplying by a number, okay? So dividing by 2 and multiplying by half is the same exact thing, alright? So now you have this page. This is your exit ticket. So here's the polygon. Draw the scale copy of the polygon using a scale factor of a half. Well, a half, what did I just say a half means? Hopefully you said divide by 2. So you are dividing each one of these sides by 2 and then creating your new one, all right? Over here, you're picking the one that it matches. Angle A, this stands for angle. I wrote it right here. Angle A matches with what? Well, A is here. Well, that matches with X. So I'm going to write X. Angle X. Okay? Remember, the word corresponds means goes with, matches with, is in the same location. So it means the same things, okay? And then what do you think it means by corresponding parts? All right. So you're going to finish this. You're going to turn it in to the substitute. And then you are going to go to this website. Same like yesterday, except this time you're going to click Wednesday instead of Tuesday like you did yesterday. Then you're going to answer the questions, press submit, and then you're done. Make sure this gets turned into the sub. And the rest of this is notes for you, and we're going to talk about it when I come back on Thursday. All right? So be good for the sub.